My name is Joel Thomas, and I'm the president here at Pride Conveyance Systems.
In the most basic terms, can you explain what is the role of conveying in a can line?
So as a can gets manufactured, it's basically going to go from an incoming coil that's raw materials to a finished can that's getting palletized to go to the filling location. So even though there's dedicated process machines, cut press, body maker, trimmer, washer, etc., the conveying transports the can from process machine to process machine through its manufacturing process. In this, we have applications where we need to do it single file. We're doing it with a wet can, a bright can, a printed can. We may have to turn the can over for getting it washed. We may have to turn the can back over. And that's it in its simplest form.
As we let this play, you just tell me what you see and what you think is important to highlight, and I'll try to do my best to let you do the talking.
This is a typical lane cup, radius cup, or discharge table, whereas the cups exit the press. Each cup is established in its own lane as it goes around the radius. And all the time we're slowing down air pressures and letting those slow down. So rather than them doing a hard 90-degree transition, it's a slow directional change going on to mass conveying, and then we're going up the cup elevator. And one of the recent changes that we've been implementing too is we've got a belt that has a large enough open area there that we're not having to use perforated holes, so we can hang onto that cup and use a lower horsepower blower. The other thing to note that we're doing differently is if you're pulling in a new coil, your first couple cycles, you're going to be getting tear offs and stuff. You don't want those cups going up the cup elevator. So you can have that as an automated gate. So if the press goes down, that gate automatically opens. First couple cycles is going to take everything into that cup chute and dump it. And then the gate would go back to a nominal open position and let good product continue to make its way downstream.
So we'll keep going up the cup elevator.
As you go downstream, you're going to notice there's all those clear Lexan sensor covers. As the cup pack builds back and we actually cover that sensor, it's going to turn off that drive so that we're not rubbing any of that lube off the bottom of the cup and risking any cup scratching.
When we look at the cup conveying, you try to use a lot of mechanical conveying. All of this section is mechanical. Is that correct?
Yes, this is going to continue to make it all the way down till we get to the distribution area where we start feeding body makers. Let's face it, the body makers are some of the most volatile machines that are in the can making process. You have lots of body makers that are started, stopped, that are up, down. So having a mechanical belt that would be continuing to move underneath these cups to feed the body makers that are downstream, we would have increased chance of cup damage. So by using this air distribution system, it always stays full, it always stays primed, which mitigates us getting any impact dents. We're keeping the whole system full and primed all the time. And it allows us to not have to start and stop conveyors. Any body maker can start and stop, do whatever they need as needed, and the cups are automatically going to be fed to each machine. And it wouldn't matter which machine goes up or down, or if there's speed changes, it's always just fed and primed as needed.
This is obviously leaving the trimmer.
This is a good example. In this particular case, we're looking at a vacuum elevator. Vacuum elevators are nice because they just hang onto the can. We're using vacuum to hold them onto a perforated belt and conveying them upstairs. The downfall to the system is, again, because we're using vacuum, we've got all the soluble oil. You're going to have a higher horsepower usage. You're going to have the mist collector. You're going to have the associated maintenance that goes with the mist collector. But there is the benefits to getting these conveyors upstairs. Some of the older stuff was a wet can trench. The biggest piece is the associated cost. Doing all that foundation work to put in trench and overall maintenance is facilitated a lot better if we can get all of that conveying up out of a wet can trench, go upstairs.
Is there a standard that new lines are being installed with?
Right now is what we call grouper elevators. That has the lowest operational costs out of anything that's there, and limited maintenance because you don't have the blowers or mist collectors either. If I had an elevator like this where I'm going to come out of the trimmer, I'm going to go up, say, to a 20-foot elevation change, we're probably looking at collectively 15 horsepower as a minimum, depending on the can. So I can do that same process with the grouper elevator with a total of 2.5 horsepower.
Explain to me exactly what I'm looking at here and what the other option for getting the cans down to the washer might look like.
The standard process would be for this to be a vacuum device, similar to what we saw in the cup elevator. It works well. It's user friendly for multiple can sizes, but the caveat is you'd have to have a mist collector. So there's the associated operating costs with that. If you're not doing a bunch of swings, we can do it with a slide. And that slide is basically you've captured the can, so it will retain the can. It's going to put the can down where you want it to be. We can invert the can. We can do lots of different things with it. This particular slide is an S shape. We're going vertical, then we're turning the cut edge back down and landing on a conveyor down below.
This is going to end up getting us straight over to the washer.
For this application, that's just going on to a mass mechanical belt. That mass mechanical belt's running faster than the washer itself. So it's pushing it out, developing the washer pack and feeding the washer. Some can sizes today, some of the taller, skinnier cans, do not like to move cut edge down on that belt. So you'll end up with a higher percentage of spoilage, those cans tripping and falling. So we do have a small air table that we use on the washer and feed table. So we can use air to move those cans around, develop that pack, establish that pattern, and then feed it into the washer. What happens on the mechanical conveyor is even though it's a plastic belt, it's not one link that runs across the entire width. It's bricklayed construction. And the cut edge of the can, as it slides from one module to the next, might want to catch on the edges of those. So a tall, skinny can like this, as it's trying to slide sideways to spread out and make that 8-foot wide pack, it's going to want to trip and fall over. Whereas if you were on an air deck, that's a flat piece of stainless. It's all one piece. It's polished and it's got a top cover. And that air, as it hits the back of the pack, is going to rush out the sides. It's going to take cans over there with it. So an air conveyor is going to be able to spread that out, populate that whole area, and create a washer pack without having a tall, skinny, sensitive can want to trip and fall over. Each washer is going to have an established pack width based on that can diameter, what the spray bar area, what the washer is set up for. To make sure that the system is efficient as possible, we would prefer not to have any voids. What's important is that the pack is in nested tight. It's actually those cans up against the other cans that will prevent those from falling over. A tight nested pack with a slight gap between each can and having that be consistent and each can sitting flat and indexed correctly is what's ideal.
This is going to be the washer discharge up to the decorator.
Typical washer discharge conveyor is shown right there. Again, it's just a cross conveyor that's perpendicular to the washer. For most nominal can sizes, that system functions well. We get into some sensitive containers. Making that 90-degree right-hand turn makes the cans want to trip and fall over. Just kind of the same challenges in generating that pack on the washer and feed. So we do have an alternate air system that can be used there. Ideally, we don't want to convey the cans cut edge down. So coming out of the washer, getting the cans turned over right away is ideal. We just had a quick glimpse of the bright can accumulation. You get some condition downstream that stops the line, the backup condition on the decorator, something else happens downstream. You don't want those cans being stuck in the oven or stuck in certain stages in the washers. The infeed will shut off. The discharge continues to run, and it gives us a place to empty the washer and the dry off oven.
Two different customers may treat accumulation slightly different. This is the die to dump the washer. What does the other option of that look like?
Another situation is where we'll use a spiral. Obviously, if you think about the footprint that the washer on the oven is, it's pretty large, right? 8-10 feet wide, 100 feet long. You need that much real estate for this bidirectional table as well. We do have an accumulation spiral, so it will literally hold more cans than this die. In cubic area, it's larger, but because it's a spiral, it stacks over the top of itself. So its footprint, when we think about it, the square area, the footprint in the plant, it's way less than a die ever thought of being. Obviously, that's more elaborate piece of equipment, but having the additional accumulation, additional flexibility, we often find that the payback analysis is relatively quick despite its increased cost. But got to fit the model and your overall operational philosophy of your line as a whole as well.
As we watch this video play, we're going to the bottom rim coat system.
Ultimately, you're going to get that can on its dome. The bottom rim coat allows you to put a varnish on the bottom of the can earlier in the process. So you gain the mobility benefits throughout the entire line. Almost every new line goes in today with it. And we're still doing projects where we're renovating and bringing it to old existing lines as well.
Now, as we go down towards the decorator infeed, can you walk me through what I'll be looking at here as we enter the decorator?
This is a small air table that feeds the ADB. It's another opportunity where we're using air to enhance the ADB's design, that it doesn't overfeed the box. It doesn't allow the box to starve for cans, that it complements itself without having to have extensive line control logic to regulate that. So cans are basically getting dumped in to the Dublin box via the waterfall. Waterfall uses various pressures and chambers to use centrifugal force and almost a cyclone effect to get those cans to single file. Then it will discharge the single file cans horizontally. Obviously, we're trying to maintain 100% density, no gapping, and that's feeding the cans down into the decorator.
We talk about the UV bottom rim coater. I've heard that also helps your air doubling box perhaps perform even better at higher speeds. Is that true?
When you get that fresh, clean can coming out of the washer, one of the things that all the conveyance systems are most susceptible to is aluminum oxide buildup. That aluminum oxide is this fresh, clean aluminum that can wear away off the can. Obviously, there's a lot going on in the Dublin box and the decorator infeed air track. So that aluminum oxide can rub off. It starts to coat the surface, which makes it abrasive. It's a buildup. It will restrict the flow of cans. So a UV bottom rim coat then coats the bottom of that can. It doesn't allow that buildup on the dome side of the box, the air track, or any of those surfaces. So it does create performance improvement having that in place.
Now here we're going to be leaving the decorator.
What we're seeing is a Pride pin stripper. It's extracting the can off the pinch in oven. We are using a large radius to maintain the can spacing that they had on the pin chain, because there's cameras that are inspecting the litho quality, the decoration quality on the can. If the cans get too close together, the camera can't see all the way around the can. So that's the imperative nature of maintaining that spacing. Cans are being inspected. Any cans with bad decoration on it can be rejected. All the good cans continue downstream. We use air track there because it allows for directional changes, get off the pin stripper, get oriented onto the mechanical conveyance. Here we're using a ART, which is where we're taking some spin off the can. We're sending those cans out on the mechanical conveyor, and that's going to allow the cans to spread out, slow down, and then get to nominal mass to make our way towards the spray machines. Here, just conversion rail single filers. That's a typical process. One of the highly utilized means of getting the cans back to single file so they can be indexed and fed into each spray machine. There's a gravity twist, elbow twist, which is used to orientate the cans and get them indexed in the right direction to feed the spray machines.
I would assume that you'd also have air conveying to help these single file as well for the ICN feed. Is that correct?
Because machines get taken down one at a time for maintenance. It doesn't matter which spray machine is running or not running. The air distribution system allows us to adequately feed cans to all the machines, regardless of which one that's running.
I appreciate all of your time today. It's fascinating speaking to somebody as knowledgeable as you. So thank you very much for your time.